Hello guys, my name is Shahrukh. In this video, I will be showing you what is trunk port, what is the use of a trunk port, how we can configure a port to be a trunk, and what are the different protocols we can run on the trunk port. So now let's start the topic. Topic is trunk port. I will take one switch over here. This is switch 1. On this switch, two users are connected. User A and user B. User A and user B. User A has an IP address 10.0.0.1. User B has an IP address 10.0.0.2. User A is in VLAN 10. User B is in VLAN 10. Both are in the same VLAN, so they can communicate with each other. When user A needs to ping to user B, so before sending the ping, user A needs to resolve the MAC address of user B. So user A will generate an ARP packet. Right over here. User A will generate an ARP packet. This ARP packet will be received by the switch on this port. Switch will see that the destination MAC address is all F, that means switch need to broadcast it. But switch will not broadcast to all the ports because this packet has been received on a port which is a member of VLAN 10. So switch will flood this packet only on those ports which are the member of the VLAN 10. So switch will send this packet over here, that is to user B. User B will receive an ARP packet. User B will reply with an ARP response. So user A will get the MAC address of user B, and so now they can communicate with each other. But if I will put user B in some different VLAN, let's say user B is in VLAN 20. So when user A will generate an ARP packet to get the MAC address of user B, switch will receive this ARP packet. Switch will see the destination is all F. Switch knows now to flood this packet on all ports, but on all those ports which are the member of VLAN 10. But over here, user B is in different VLAN, so switch will not forward this packet to this port. So now the communication will not happen. Okay, this is by default behavior. Let's say I will take one more switch over here. Same, two users are connected over here, user C and user D. User C, user D. User C has an IP address 10.0.0.3. User D has an IP address 10.0.0.4. User C is in VLAN 10. VLAN 10. User D is also in VLAN 10. Now user C and user D can communicate with each other because they both are the member of same VLAN. But if I put user D in some different VLAN, that is VLAN 20, so now user C cannot communicate with user D because they both are the member of some different VLAN. Now my requirement is user A should communicate with user C because they both are the member of same VLAN. So what we can do, first of all, I need to connect both the switches because both the users are located on different switches. So first I need to connect both the switches. Now after connecting the switches, still user A cannot communicate with user C. Let's assume user A will ping to user C 10.0.0.3. Before sending a ping, user A needs to resolve the MAC address of user C. So user A will generate an ARP packet over here. Switch will receive this ARP packet. Switch knows now to flood this packet because it is a broadcast packet. So switch knows now to flood this packet on all those ports which are the member of the VLAN 10. Switch will not flood this packet on this port where user B is connected because it is in VLAN 20. Switch will not forward this packet on this port also because by default this port will be a member of VLAN 1. So switch will not forward this packet on this link. Let's say this link is E0 by 0. So switch will not forward this packet on E0 by 0 because this port is a member of VLAN 1. Similarly, if user B wants to communicate with user D, user B will generate an ARP packet. Switch will see that this is a broadcast packet. Switch knows now to flood this broadcast packet to all those ports which are the member of VLAN 20, but this port is a member of VLAN 1. So switch will not forward this packet on E0 by 0. So what we can do if we want to have a communication? One thing I can do, if user A wants to communicate with user C, what I will do, I will put this port in VLAN 10. I will put this port in VLAN 10. So now what happened? When user A will generate an ARP packet, switch will receive it. Switch knows now to flood this packet on all those ports which are the member of VLAN 10. So now this time switch will forward this packet on this port also, which is E0 by 0. This is E0 by 0. So now this time the ARP packet will go over here. So now switch C can receive this packet. Now the communication can happen. Similarly, if user B needs to communicate with user D, so what we can do, I will remove this port from VLAN 10 and I will put this port in VLAN 20. Now user B can communicate with user D, but at a time user A can communicate with user C or user B can communicate with user D, because this port can be a member of only one VLAN, because by default this port are the access port, this port are access port, and access port can be a member of only one VLAN. So what we can do, we have one more solution. The solution is we can add up one link over here. We can add up a link over here. I will put this link a member of VLAN 10 and I will put this link a member of VLAN 20. So now VLAN 10 members can communicate with each other. Similarly, VLAN 20 members can communicate with each other. No issue. But let's assume if I am having here 20 VLAN, 1 to 20. Similarly, I am having here 20 VLAN. So what I can do, I cannot take 20 links like this. Per link belong to per VLAN. This is not a solution. So now what to do? We have another solution. What we can do, we will make this port as a trunk port. This port and this port as a trunk port. And by default, trunk port is a member of all the VLANs, that is VLAN 124094. So now what happened? If user A wants to communicate with user C, A will generate an ARP packet, switch will receive it. Switch knows now to flood this packet on all those ports which are the member of VLAN 10. Switch will not forward this packet over here because this is VLAN 20. Switch will see this port is a trunk port, and trunk port is a member of all the VLAN 10, 20, 30, etc. all the VLAN 124094. So now this time switch will forward this packet over here. Similarly, if PCB needs to communicate with PCD, the switch will receive this packet, switch will flood this packet over here because this link is also a member of VLAN 20. So now you come to know what is the use of trunk, why we make a link to be a trunk, because trunk port is a member of all the VLAN. It can carry all VLAN traffic. Otherwise, if we just make this link as an access port can carry only a single VLAN traffic. It can either carry VLAN 10 or it can either carry VLAN 20. So to achieve this, we need to make this link as a trunk link. Okay, and trunk link is by default member of all the VLANs. Now let's assume when PCA sends an ARP packet to switch, this is switch 1, this is switch 2. Switch receive it, switch will flood this packet on this link which is a trunk link. Switch 2 will receive it. How switch 2 will come to know that this packet belongs to which VLAN? VLAN 10, VLAN 20, VLAN 30, VLAN 40. How switch 2 will identify? So when this packet will send over the trunk link, this is a packet which is going in a trunk link. So what will happen on trunk port? There are two types of protocol, either ISL or DOT1Q is running over here. They will just tag the information that this packet belongs to VLAN 10. Similarly, if it is VLAN 20, then they will tag the packet as VLAN 20. So that on the other end, switch 2 can identify, okay, this packet belongs to VLAN 10, so it will deliver this packet over here. It will not deliver this packet on this port which is a member of VLAN 20. So by tagging the packet, the other end switch can identify to which particular VLAN this frame belongs to. Okay. So now we will see what kind of protocols running on a trunk port. There are two different kind of protocol. One is ISL, another is DOT1Q. ISL is Cisco proprietary, whereas DOT1Q is open standard. ISL supports native VLAN. ISL supports native VLAN. DOT1Q does not support native VLAN. What this means? By default, on every switches you will find a native VLAN, and by default it is 1. When a packet of native VLAN goes on a trunk link, and if on that trunk link ISL is there, so ISL will tag that packet. But if on trunk link DOT1Q is there, so DOT1Q will not tag that packet. It will send as it is. So by default for VLAN 1, ISL does tagging, and DOT1Q doesn't do tagging for VLAN 1 by default. If you wish, you can do it. ISL supports VLAN 1 to 1001, whereas DOT1Q supports VLAN 1 to 4094. ISL, this is the earlier version of ISL which supports only VLAN 1 to 1001. Nowadays, ISL also supports VLAN 1 to 4094. DOT1Q supports 1 to 4094. ISL encapsulate the frame. ISL will encapsulate the frame. DOT1Q does not encapsulate the frame. Does not encapsulate the frame. ISL, while encapsulating the frame, it will add 26 byte of ISL header plus 4 byte of ISL trailer, that is total 30 bytes. Whereas DOT1Q just add the information of DOT1Q in the middle of the frame, which is only 4 byte. It's only 4 byte. Nowadays ISL is as good as absolute now, nobody use it. But these are some differences between the ISL and DOT1Q. Okay. Now let's move on. When a PC generates a frame, the frame will look like this. Here you will see DA, that is destination MAC address, SA, source MAC address, here type field, here you will see data, and here you will see FCS. What is this FCS? Frame check sequence. When the device is sending a packet, when the device is generating a frame, it will add a field called FCS, which is a 4 byte. What exactly happens? An Ethernet will run a CRC algorithm on this entire portion, and it will come up with a value. Let's say the value is A. On the receiving end, the receiving device will run the same CRC algorithm on this entire portion, and it will check the value. If it is same, that is no problem. But if it is different, that means this frame has been damaged in the transit of the link. So this is the use of FCS field, which will indicate that the frame is damaged or the frame is proper. Okay, this is an original frame generated by the user. Now if I'm using an ISL protocol, then the frame will look like this. This is DA, destination MAC, source MAC, type field, data, FCS. Let's say FCS value was A. This is a 4 byte 32-bit number will be there. Now what ISL will do? ISL will encapsulate this frame with this ISL header, which is of 26 byte, and in the end it will add an ISL trailer. It is of 4 byte. ISL trailer is same as FCS. In this ISL trailer, the ISL, you will see it will run the same CRC algorithm, but this time the CRC algorithm will run over this portion, the entire portion which ISL has encapsulated, and it will come up with a value. Let's say the value came is A. On the other end, the ISL will rerun the CRC algorithm on this entire field. It will see that the ISL trailer information matches the same information which he has calculated. That means it is correct. It will remove this ISL trailer. It will check ISL header. It will remove it. It will forward this. It will forward the frame according to the MAC address. Okay, so this is how ISL behave. ISL will add a 26 byte of header in the beginning of the frame and the 4 byte of trailer at the end of the frame. Now if you will see DOT1Q, DOT1Q doesn't encapsulate the frame. This is a frame. Here you will see DA, SA, After DSA, DOT1Q will add its information. DOT1Q, I'm just writing dot. This is a 4 byte. This is a 4 byte. After this, type. After this, data. After this, FCS. This is DOT1Q. See, when the sending device has generated an FCS, when the sending device has generated an FCS, let's say FCS A, so it has run the CRC algorithm on this portion. Now on the other end, the switch receives this frame, it will rerun the CRC algorithm on this entire portion. So now this FCS field will be different. Let's say it come up with a B, that means it is not correct. So what exactly happened? I will make two switches. This is user. When this user has generated this frame, it comes to switch. Switch will send this frame on the trunk link. Before sending the frame, it will add a DOT1Q tag. It will rerun the FCS field on this entire portion. It will rerun once again the CRC algorithm, and it will come up with a value, and it will put a value in this field. Let's say is C, and it will send on the trunk link. On the other end, switch 2 will receive this. Switch 2 will rerun the CRC algorithm on this entire field. It will see that the FCS matches, that means the frame is correct, there is no issue in the transit of the frame. So this is how DOT1Q behaves. We will see DOT1Q in more detail. See, DOT1Q header is of 4 byte, because nowadays everyone use DOT1Q. This 4 byte is divided into two portions. This is DPI and this is TCI. This is of 2 byte, this is of 2 byte. DPI stands for tag protocol ID and TCI stands for tag control information. Sorry, my writing is not good. Tag control information. In this DPI, you will find a type field. This DPI is just an indication that this frame belongs to DOT1Q. Here you will find a type field of DOT1Q, which you will see 0x8100. You will see this information in the DPI field, and this TCI is broken into three parts. This TCI is broken into three parts. This is COS, which is of 3 bit, and another is CFI, this is of 1 bit, and here you will see VLAN ID, it is of 12 bit. COS everybody knows, to prioritize the traffic. CFI stands for canonical factor indicator. This field is for the backward compatibility with token ring. Nowadays we don't use token ring, so you will always see this field as 0. And finally, this is 12-bit VLAN ID. Why the VLAN ID is 12-bit? Because the VLAN range is of 2 raised to 12, that is 4096. Okay, So this is the breakup of the DOT1Q header. Now you came to know what is the difference between ISL and DOT1Q, how both behave on a trunk link, what is the use of trunk link, why we need to use trunk link, because trunk link can be a member of all the VLAN and an access port can be a member of only one VLAN. So if we will connect two switches, so we will always configure the link to be a trunk, otherwise it will be an access port, so only one VLAN information can be carried. Okay, so now let's move on. We will see some practical of this trunk. Just hold on. Let it be. See, I'm having one setup over here. I will take a screenshot of this. This host has an IP address n dot, just hold on. This host has an IP address 10.0.0.1. This host has an IP address 10.0.0.2. This has an IP address 10.0.0.3. This has an IP address 10.0.0.4. Now what we will do on these two switches, we will configure this port as member of VLAN 10. We will configure this port as a member of VLAN 10. We will see that they both can communicate with each other, but when we make this port as a member of VLAN 20, so now host 1 and host 2 is unable to communicate with each other. Similarly, we will see on this port also when they both are the member of same VLAN, so they will communicate. When we will put host 4 in VLAN 20, so it will unable to communicate. Then we will check that this host A can communicate with host 1 can communicate with host 3 because they will be member of both same VLAN 10. Then we will see host 2 can communicate with host 4 because they are the member of same VLAN, it is VLAN 20. So by default they will not communicate with each other because this link will be by default an access link which is a member of VLAN 1. So what we will do, we will make this link a member of VLAN 10. So we will see host 1 and host 3 can communicate with each other. Similarly, when we will make this link a member of VLAN 20, so host 2 and host 4 can communicate with each other, but this time host 1 and host 3 is unable to communicate with each other. So finally we will make this link as a trunk so that host 1 and host 3 can communicate. Similarly, host 2 and host 4 can communicate with each other. Okay, so now let's start practical. I had already configured an IP address for all these four hosts. I just need to go switch 5. I'm on switch 5. Show CDP neighbor. On E0 by 1, host 1 is connected. On E0 by 2, host 2 is connected. I'll put host 1 E0 by 1 switch port mode access. Switch port access VLAN 10, member of VLAN 10. Similarly, I will go on E0 by 2 switch port mode access. Switch port access VLAN 10. Now both are in the same VLAN, so host 1 can communicate with host 2. Let's see. Ping 10.0.0.2. Show IP interface brief. It has an IP address 10.0.0.1 on host 2. Show IP interface brief. Host 2 also has an IP address. I'll check on switch. Show run interface E0 by 1. It is member of VLAN 1. E0 by 2 is the member of VLAN 10. Okay, perfect. We'll try once again. Ping 10.0.0. Okay. This time host 1 is able to communicate with host 2. Now what we will do, we will put host 2 in some different VLAN. It is E0 by 2 switch port access VLAN 20. This time host 1 will not able to communicate with host 2. Just see. Now they both are unable to communicate with each other because now they both are member of different VLAN. Similarly, we will do on switch 6, which is this switch. Switch 6, we will put host 3 in VLAN 10, host 4 in VLAN 10, and we will see switch 6. Config interface range E0 by 1 slash 2 switch port mode access VLAN 10. Now we'll ping to host 4, ping 10.0.0.4. Just wait. The port is in learning mode because of the spanning tree, so it will take 30 seconds to bring the port to forwarding state. Just hold. Okay, so now you can see host 3 is able to communicate with host 4. If I will put host 4, a member of VLAN 20, so now they will be unable to communicate. Interface E0 by 2, switch port access VLAN 20. Now host 3 will be unable to communicate with host 4. Now we will see that host 1 can communicate with host 3 because they both are the member of same VLAN. We will see host 2 can communicate with host 4 because they are also the member of same VLAN. We'll go on host 1, we will ping 10.0.0.3. Host 1 is unable to communicate with host 3 because his link is member of VLAN 1. That's why host 1 is unable to communicate with host 3. Similarly, we will see on host 2 in 10.0.0.4. Host 2 is unable to communicate with host 4 because this link E0 by 0 is a member of VLAN 1. On this link, only VLAN 1 traffic is allowed. Okay, so what we will do, we will first make this link a member of VLAN 10 so that host 1 and host 3 can communicate. After that, we will make this link a member of VLAN 20 so that host 2 and host 4 can communicate. Let's see. Switch E0 by 0, both the ports on both the switches. Interface E0 by 0, switch port mode access, switch port access VLAN 10. Similarly on switch 6 you will see interface E0 by 0, switch port mode access, switch port access VLAN 10. Now this link belongs to VLAN 10, native VLAN mismatch, let it be. Now you will see host 1 can communicate with host 3. As you can see, host 1 is able to communicate with host 3 because now this link, the link between both the switches, is a member of VLAN 10. But host 2 will not communicate with host 4 because they are member of different VLAN. It is VLAN 20. As you can see, host 2 is unable to communicate with host 4. Now what we will do, we'll put a link between switch 5 and switch 6 in a different VLAN, that is VLAN 20, so that our host 2 and host 4 can communicate. Interface is 0 by 0, switch port access VLAN 20, interface is 0 by 0, switch port access VLAN, switch port access VLAN 20. Now you will see that host 2 can communicate with host 4. As you can see, now host 2 can communicate with host 4. Now this time host 1 is unable to communicate with host 3 because now the link between both the two switches is a member of VLAN 20, so it will not carry the data of VLAN 10. As you can see, this time host 1 is not able to communicate with host 3. Earlier you will see we are getting the ping response, but this time we will not see anything. So now what's the solution? The solution was to configure a link between these two switches as a trunk, because as I said you, trunk link is a link which carry data of all the VLAN, that is VLAN 1 to 4094. So now on this link VLAN 10 data will also be on this link, VLAN 10 traffic will also go, as well as VLAN 20. So now let's configure this link as a trunk. Switch 5. We will remove this configuration. Default interface is 0 by 0. This time we will configure trunk. While configuring trunk, you need two commands. First, you need to define what kind of encapsulation protocol you are running, DOT1Q ISL. Another command, what is the mode of this interface. It is by default is access, so we need to change to trunk. If I will first define the mode, then it will give an error message. I will show you what this error message means when I will make a video on dynamic trunking. So first we will define the encapsulation protocol, switch port trunk encapsulation DOT1Q, switch port mode trunk. Similarly on switch 6, first I will remove the configuration. All interface is 0 by 0. E0 by 0, switch port trunk encapsulation DOT1Q, switch port mode trunk. Now this link will be trunk. How you can check it? Simply by show interface trunk. You will see port E0 by 0, the status is trunk. By default VLAN 1 is a native VLAN. Encapsulation protocol we are running is 80.1Q. The mode is on, which means I have made this link a trunk but by static. It has not become trunk by dynamic. It has been configured as a static trunk. I will show you what is dynamic trunk when I will make the next video. Okay, so now this time you will see host 1 can communicate with host 3, as you can see. Similarly, host 2 can communicate with host 4. So now you have seen that by configuring this link as a trunk, by configuring this link as a trunk, my VLAN 10 traffic and my VLAN 20 traffic has been carried over here. Similarly, when I make this port as a trunk, on this trunk link, my VLAN 10 and my VLAN 20 has been carried. This is 4. So that's it for the trunk. Now you came to know what is trunk, what are different protocols we can run on a trunk port, what is the use of trunk port, how to configure trunk port. One more thing I will show you. This is not a real switch, so it doesn't support ISL, but I will show you the command to change. You just need to change the encapsulation protocol. On switch 5, you will just do switch port trunk encapsulation ISL. That's it. Interface E0 switch port trunk encapsulation ISL. Now on this link, ISL is running. This is not a physical switch, so this switch doesn't support ISL, but only commands are accepted. If I am able to ping, if I will see that host 1 and host 3 can ping each other, so I will not get a ping response because this switch doesn't support ISL. But if you will check it on the real switch, so you will definitely see the ping response. So you just need to change the encapsulation protocol on a trunk link. That's it. And one more thing, over here you cannot define DOT1Q, and over here you cannot define ISL because DOT1Q tag ISL can't understand and ISL tag DOT1Q can't understand. So on both the end you need to configure the same type of encapsulation protocol. Okay, that's it. Thank you. I will see you next video where I will make dynamic trunking.